Good evening, everyone. Good evening. Hope all is well. Hope everything's going all right. So, hope you're ready to get this semester started. I guess at this point, 5:30 in the evening, you've already gotten things started. So, my name is Mr. Tucker. I will be your instructor for these 16 weeks. Like I said, it's good to be here. Hope you guys feel the same. So, send out emails, and I'm assuming that everybody got them because you guys are here for the Zoom information with that Zoom information. Um, Also, let's make sure we go through MathLab stuff before we go any further. But you got the information on the greeting, let you know how this class will be ran. We'll meet every Monday, Wednesday virtually. So it's not just online, but we're doing it virtually. In other words, we're going to meet at the appointed times and actually have a lecture. Also, your class will be the foundation of the class and everything that's done through it will be done through my math lab. And so where it goes, no, I want this one, not this one yet. All right, so one of the emails that I sent you guys, and I believe most of you got it because you logged on this math lab already, was this one called MathLab Access, your required materials. So you have to purchase my MathLab or access to MathLab. Even if you don't purchase the text, you at least have to purchase access to MathLab. Now your course ID, this is not the correct one for you guys. Your course ID was something different. I don't even have it on this page, but it's not that. This is just a generic email I pulled up. But if you haven't registered, you go to mymathlab.com, click on register now, type in your course ID. Then from there, you have three different options. You either type in the access code that you've already purchased through an outside source, whether it be the bookstore, Amazon, or a friend, or whatever the case may be. If you don't have that, you can purchase access through Pearson itself. In that case, they wouldn't give you access code; they would just give you access. And then if you don't have the access code, not ready to purchase it yet, you can use the 14-day free pass. So that's that there. Of course, if you have any issues with registering for my math lab, let me know. Also sent you this one, which is called the Math Lab Specifics. Basically, just talking about how we will be using Math Lab in the course. So of course, you cannot pass the course without access to my Math Lab. All the assignments, any tests, or anything that we do will be generated through Math Lab. In order to solidify your attendance, you must participate or show activity in Math Lab. Reason being is because, yes, I will look at attendance through Zoom, but I will be recording these lectures and I will send them out to you. So let's say if you miss class, but then you look at the lecture, there's no way for me to know that you actually looked at the lecture, which to me is just like attending class that day. So what I would do is, for the most part, I will go to Math Lab and look at your attendance. So if you haven't attended class, wasn't able to attend class all week for whatever reason, and there's no record of you going to class, what you can do is go into Math Lab and at least put a timestamp on your attendance activity, at least go in there, go into a homework, save it and come out, something of that nature to show that you are active and you're still around. If you're having issues with anything, whether it's attendance, Math Lab, or whatever the case may be, please let me know. Keep lines of communication open. People, every class, every year, I have people that fall off the face of the earth. They end up just disappearing. They stop attending. They stop submitting in Math Lab. They don't ever withdraw. And then from there, all I can do is give them an F. So in order for me to not put you in that category, please just let me know that you're still around. Just having a few issues. Don't have to give me deep, intimate details about what's going on, but you can let me know that you're still around. You're still trying to make it happen. Just having a few issues, and I'll do whatever I can to work it out with you. All right. So your homework, you have unlimited amount of tries to get the best grade possible on your homework. When it comes to your homework, scores you want to shoot for is at least a 75 to 84.9. I will call that a 90 in my grade book. And then 85 to 100, I'll give that 100% full credit. So you at least, if you want to get full credit, you at least want to shoot for the 85. But if you want to get credit, period, you want to shoot for at least a 75. And that's marker I try to leave it at. Things, maybe there is an assignment or two that may be real hard. Maybe we'll talk about it or whatever. But for the most part, this is what we're looking at. Reason being is because you have unlimited amount of tries, to get the best grade possible, but you don't have unlimited amount of problems. So eventually, if you keep clicking on it, truth be told, that problem will pop back up again, right? So that's why we do it. That's why I do it at 75. Test reviews, we'll post a test review for each test. They're not mandatory, but if you decide to do it, score 85 or better, I will add 5 points to your test. Your tests that aren't proctored, you get 2 attempts to get the best grade possible. Unproctored tests. So proctored tests, for example, would be like your final exam when I'm supposed to be looking at you actually take it. So, but your proctored tests, unproctored tests will be tests that you can do on your own time. And just remember that whatever test you have, make sure you send me a copy of your scratch work for any test submissions. All right, whether it's proctored or unproctored. All right, any questions on anything that I mentioned here? Anything, anybody? All right. Trying to find my MathLab. You kick me out. All right, so when you get in there, you'll see all of your homework assignments. Right now we have chapter 2, chapter 3, and chapter 4. We'll see if we're able to get to chapter 5. We should be able to. I think last time we taught it, we had a bunch of stuff going on that prevented us from being able to get to chapter 5. I think that was the first semester with COVID and all that stuff like that. So we only got a chance to get to chapter 4, but we most definitely would do 2, 3, and 4. But you see how we have a test review set up as a homework in each case. And then from here, let's look at our test. What do I have posted? Okay, I haven't posted any tests yet. So I'll probably more than likely I'll post chapter 2's test for sure. So that you can do it on your own, unproctored. Let's go here, course tools. All right, so go ahead and put chapter 2 up there. That's our first test. So you have access to that. When you're ready, of course, you don't just jump in there and just do it yet. So the way we will normally handle our due dates, notice the due date is 12/19. So our first due date will be midterm. So I'll have a hard due date at midterm, and then the next due date will be our final day. And so that's normally how I do due dates. So we just have a solid due date. So I just need to go in and look that up. So right now it's 12/19, but chapters 2 and 3 most definitely. Yeah, chapters 2 and 3 should be before that midterm due date, but we play by ear and see. For sure, chapter 2 will be. All right. So let's see the way MathLab works. If you haven't dealt with it, let me see. Okay, I think haven't I had all of you guys? I think I've had all of you guys before. Y'all seen my MathLab. Anybody need to see MathLab? Anybody not familiar with it? Very good. Okay. All right. So I think we're good on that front. So any questions on anything before we look at 2.1? Just doing that, generic run through of introducing the course, making sure everybody's okay. And we don't have any questions. Everybody good? All right, so. I went back through these notes, and I realized that I had to rewrite a lot of it because I think I must have Yeah, it was the first time using this computer. Man, some of my handwriting was tough. I think I was just getting used to writing, excuse me, on this screen. So 2.1, rates of change and tangent lines to curves. So we'll do 2.1 today. And that'll be a nice springboard into going into the next class. And also I had a conflict that I didn't know about, a situation I have to take care of. So we won't hold a long class today, but it's only the first day, so we don't have to be here the whole time. All right, so average rate of change, the way we calculate that, and you guys have seen it before because it's your slope formula. Actually, we have delta y over delta x, which means, did I write it down here? I didn't write it. So whenever you see a delta, it also means change in. So in other words, that's a change in y over the change in x. All right. And I don't know why I wrote this stuff so sloppily, but like I said, I think I was just getting used to writing on this screen. But the change in y over the change in x is going to be y2 minus y1 over x2 minus x1. Also a way of writing it. That's what I was writing right here. Y and f of x are the same, so don't forget function notation. So you may see f of x2 minus f of x1 in place of y2 instead of y1. In place of y2 and y1. So these two are the same. And these two are the same. So that's what we're saying here. What was that? No. All right. And also don't forget, I can't see most of you. So if I do scroll up and you're still copying, always feel free to unmute or type in the chat to let me know. All right. Another way of representing it is f of x plus h minus f of x plus 1. Wait, f of x1 plus h minus f of x1 over h. And if some of you remember from last session, that's our difference quotient. Remember I told you we would use that again when we get into calculus. We're gonna use that to help us find the slope. All right. So we use that difference quotient to calculate the slope of the secant line between 2 points on the graph of f. All right. All right, so secant line is a line joining 2 points of a curve. So it's a little diagram right there. All right, and a tangent line is a line that just touches the curve at that point. All right. So looking at this first example, ended up writing the directions afterwards. It says find the average rate of change of the function over the given interval. So they give us the function f of x is equal to 4x cubed plus 4, and they give us the interval of 3, 5. So that is an interval right here. So that's not x, y, that is an interval x1, y1. I mean x1, x2, excuse me. x1, x2. All right, so we're looking for the average rate of change. So remember what we need is the change in y over the change in x. So what we want to do first is to plug in x1 into our function. So that's what we did here. That's going to be f of x1. So 4 times 3 cubed plus 4. 3 cubed is 27. 4 times 27, 108. Then 108 plus 4, be 112. All right. Then we're going to plug 5 into the function. So this is, my green, f of x2. So 5 cubed, 125. 4 times 125, 500. 500 plus 4, 504. Any problems so far? Make sure we're okay. So now we can go ahead and do f of x2 minus f of x1 over x2 minus x1. And this is the same thing as y2 minus y1. Just trying to give you guys all the notation. So 504 minus 112 over 5 minus 3. And that's 392 over 2, which is 196. All right. Questions? Any questions? Okay. All right. So that's it for that one. All right. So the next one, find the slope of the curve at the given point and equation of the tangent line. So they give us y equal to 5x squared plus 5, and they give us the point P, which is 5, 130. So this time, this is not x1, x2, but this is x, and this is y. That's an actual point. It says point P. And notice we're using parentheses instead of those brackets. So the bracket was our was an interval, x1, x2. This is the actual point on the Cartesian coordinate plane, which is x and y. All right. So we can go ahead and use our difference quotient. Start off by using our difference quotient. And so all I was pointing out right here is that y and f of x are interchangeable. And we talked about that a few minutes ago. And our difference quotient is f of x plus h minus f of x over h. So they give us f of x, which is, this right here. So we got this part, but we need to plug in x plus h and simplify that. And that's what we're doing right here. So I plugged x plus h in for x. So that's 5 times x plus h squared plus 5. So x plus h squared is x plus h times x plus h. So if you were to expand that out, that actually will give you x squared plus 2xh plus h squared. And then distribute that 5, that'll be 5x squared plus 10xh plus 5h squared. And then plus 5 is still back here. All right, any questions before we keep going? All right, so we put it back, we'll put that into the formula. Remember we had this piece, now we just found this piece. That's what we have right here. F of x plus h is 5x squared plus 10xh plus 5h squared plus 5 minus f of x, which is 5x squared plus 5, and all that is over h. So don't forget to distribute that negative into the parentheses that follow the minus sign. Let me do this. So I'll say terms. So all terms without h should cancel. So you notice 5x squared and minus 5x squared cancels for us. And then we have 5 and negative 5 will cancel for us. And that leaves us with 10xh plus 5h squared. And that h should divide into each. That'll be 10xh over h plus 5h squared over h. And that reduces down to this, 10x plus 5h. All right, any questions before we keep going? Make sure we're okay. Mhm. Part of the difference quotient, I know I mentioned it back when we did it last session, last class, pre-calc. Part of the difference quotient is that h goes to 0. So you want to evaluate this as h goes to 0. So in other words, we're going to plug in 0 for h. This is why that this h down here in the denominator had to cancel out, because we're going to plug in 0 for h. And that leaves us with just 10x. So 10x plus 5 times 0 would just be 10x. So this represents our slope. M is equal to 10x. Oh, didn't we do that? Okay. So I don't know if I like that, but anyway. So there will be times, well, it just depends on how deep you go into calculus. There will be times where there will be an x and a y involved in your slope or your difference quotient and everything like that. But in this case, all we have is x. I think as far as the problems you guys will see, what we'll all you will see is x. So we had this point of 5 and 130 initially given to us. That was point P. So we take 5, plug that in for x, and 10 times 5 is 50. So our slope is 50. I'll probably go green. Blue. All right, any problems? I don't like that. All right, so now we want to go ahead and find the tangent line. Remember, that was the last part of what we're trying to find. So in fact, let me go back to our directions. Slope. Yeah, we found the slope and found the equation of tangent line. Okay. So that's our slope. All right, so now we're going to go ahead and find that tangent line. So our slope is 50. And the point that we have, x1, y1 is 5, 130. So now we go back to algebra and use that point slope formula. Y minus y1 equal to m times x minus x1. We plug in the values accordingly. All right, so that's y minus 130 equal to 50 times x minus 5. Distribute the 50. Y minus 130 equal to 50x minus 250. Add 130 to both sides. And our tangent line is going to be 50x minus 120. All right. Any questions? Any questions? All right. So I'm going to give you one more thing before we leave. Give you an application for average rate of change. Okay. All right, so average speed when f of t measures the distance traveled at time t. Oh shoot. Average speed over t1, t2. So that's your interval. That's time passed. Distance travel elapsed. Distance travel over the elapsed time will be represented by f of t sub 2 minus f of t1 or sub 1, and then that will be over t2 minus t1. All right. Okay, so a rock breaks loose from the top of a tall cliff. What is the average speed for A during the first 2 seconds of fall? We'll look at A first, then we'll look at B. All right, so let me give you a formula. Could have called that, let me do this instead of Y. I'm call it f of t. All right, so formula, the distance that an object falls in feet in t seconds is going to be f of t equal to 16t squared. All right, so if we want to know the average speed during the first 2 seconds of fall, so if we talk about first 2 seconds, that means our interval is going from 0 to 2. All right, so let me see, do I want to write that all the way out? So we're going to lean on this right here instead of me writing it out, f of t 2 minus f of t1 over t2 minus t1. So don't forget when it's in this setup, This is T1. This is T2. So the one that follows is always T2. So that's going to be 2 squared minus 16, 0 squared. So 2 minus 0. All right. So it's going to be 4. It's going to be 64 minus 0, 2 minus 0. That should be feet. Yep. Feet per second. All right. Any problem with that before we look at B? All right. Yeah. See how they wrote it. Oh, let me write that better. I'm sorry. So during the 1 second interval between second one. Let me write it the way they wrote it instead of shorthanding it. All right, so now we're looking at the 1 second interval between second one and second two. All right, so we're talking about from second one to second two, and we're talking about 1 to 2. And this time T1 is 1, and T2 is 2. Try to keep up with how I did it last year. Changing Y. So you go ahead and plug in, same way we did last time, just that T1 is 1 this time instead of 0. So 16 times 2 squared would be 64. 16 times 1 squared, 16. 2 minus 1 is just 1. These should be 48. And this is feet per second. And so that was just an application of how your change in, well, average change rate will work for us. All right. So questions or anything? Everybody all right? Okay. So hopefully this was a good little start on what we'll be doing moving forward. So that's 2.1. Get in there, see if you have any questions, see if you have any concerns, and of course, if anything pop up, always feel free to email me if you don't want to wait till next class. But yeah, man. So let's go ahead and get rolling and get into this semester, and I believe we'll have a good one. Anybody have anything before we close out? All right. All right. So you guys have a good one. Be safe, and I will see you 5:30 on Wednesday. Take care.